Welcome back to Lokad TV. The progress made in generative AI in the last 12 months is an extraordinary feat of technological progress. LLMs, or large language models, have gone from niche to mainstream in under a year. Here to explain the significance, particularly in a supply chain context, Lokad's very first CTO, Rinat Abdullin. Rinat, welcome to Lokad.
It's a pleasure and honor to be back. I was in Lokad when it was just starting in a small, tiny room, I think in the University Hall. And in all the companies, between all the companies that I worked since, like including 7 startups, Lokad was the most challenging and rewarding place in my life.
Well, and you don't have to say anything about Joannes directly, but when you say it was the most challenging, what exactly made Lokad so challenging? And then, in contrast, the difficulty of future projects.
We were a startup back then, and it was an interesting combination of trying to find a match between the technologies and the customer, what customer wanted and what customers actually needed. And balancing this triangle was always a challenge. Because technologies back then, we were one of the first customers, big customers of Azure, just starting to build out, scaled out library for processing lots of time series from the customers. And there were no support, everything had to be built from scratch. And that journey took many years, that it continued with creating a custom DSL to empower experts at Lokad, and it's still ongoing. So that's one part of the triangle. The second part was that customers want better numbers. They want to have their business running in predictable way without any frozen money on the inventory. And at the same time, they want these numbers to be understood. Because if you provide customers with some numbers that come out of magical black box, the execs might say, yep, it works, but the supply chain experts down at the places, at the local warehouses, they say, no, I don't understand these numbers, I don't trust the formulas, and my gut feeling that is based on 10, 20 years of expertise, it's going to say, nope, it's not going to work. So I'm going to ignore this, and you can fire me. Obviously, nobody will do that. And balancing between these three, has been a challenge at Lokad, and it has been a challenge with all the customers I've been working ever since.
Well, Joannes, I heard listening to Rinat that we used to work with time series. Is that true?
I mean, Lokad was literally founded as time series forecasting as a service. So I know a thing or two about time series. Even if we did depart years afterward, yes, we have been doing time series. And again, time series is a very basic building block. And the tension that Rinat mentioned about the explainability, it's also something that was kind of finally addressed, but more than a decade after Lokad was founded. We had to embrace differentiable programming so that we had finally models that were machine learning but explainable. But it came very late. I mean, for years, we literally had the choice between, I would say, crude models or that were white box but not very good, or machine learning models that were better but black boxes and creating tons of operational problems. And sometimes they were not necessarily better according to all the dimensions of the problems. So that was an immense struggle, and the Lokad journey has been, I mean, it has been almost a decade of uphill battles. So Rinat did the first half a decade of uphill battles, and then there were other people who keep fighting for the other ones. But yes, it has been a very long series of massive problems to be addressed.
Well, Rinat, thank you, and to come back to you, Rinat. I know the way we try to explain what Lokad does is through a series of very long articles, lectures, discussions like this. But when you're trying to white box what it is, or when you're trying to white box machine learning in this context, how do you approach that?
Okay, one of the approaches that worked quite well when I've been helping to create a hackathon for international logistic company was through the simulations. So when you talk about the international logistics, there are lots of variables at play. You have cargo, which has to be transported between multiple locations using multiple modes of transportation. You have trucking companies and different other companies that are competing on the open market, bidding for the cargo deliveries from location A to location B. Then you have actual delivery pathways. It's roads, rail networks, maybe last mile delivery somewhere. And as trucks bring cargo between these locations, you would get delays, traffic jams. The cargo might arrive to a warehouse outside of the working hours, or the warehouse unloading area might be packed. And we wanted at a couple of events to model all this complexity in a way that is approachable for the students or new hires to the company. And what we've done is what's rather brutal. It's maybe a bit similar to how ancient researchers were trying to model the number of P by flipping a coin through a simulation. So we built a virtual map of Europe with primary roads. And in this virtual map of Europe, roads had lengths, the time would be passing, the trucks would drive back and forth, and the truck fleeting companies would be able to decide which cargo am I picking and if I'm going to deliver it. At the same time, that was the entry point for the hackathon participants, because they could code agents that would make decisions like, I'm truck driver A, and I'm going to pick this cargo from location A to location B. But there was a trick. When truck drives cargo from one location to another, just like in the real world, it costs money to earn money. You have to pay taxes, you have to pay for the fuel, you have to make sure that the driver, for example, rests. And we were able, because it's a simulation, you don't need complex formulas because you're brute forcing the reality. You just execute like a path script to NPCs or to a game sequentially. And you can have lots of explainable rules on a sheet of paper. And this entire world was so understandable to people, so that we actually created two levels of the hardness. In the first level, companies would be simply driving trucks, trying to make most of the money. And in the second level of the game, gas prices went a bit higher. The companies had to compensate for the CO2 emissions, and the truck drivers could get tired. So if the truck driver was driving for more than, I think, 12 or 14 hours, then there's this increasing chance of accident. And when there is an accident, truck driver goes into rest. The machine does nothing, essentially wasting time. And so we built this environment. Participants were able to code their agents. And when you run a discrete event simulation at an accelerated rate, you essentially get months of time of virtual time that pass in seconds of real time. So we were able to quickly spin lots of simulations and say, hey, teams, the decisions that your agents were making in this virtual world, these were the lead time distribution. This was the price distribution. These were the margins. These were the number of accidents that your agents was getting. And that's essentially the approach that I'm normally taking when I need to try to explain somebody a complex environment. It's first start with a simulation because it's game-like. It's easy to explain the rules. You don't have to do. You don't need to do any differential programming. But when you run this simulation, it's essentially a Monte Carlo analysis, but that tracks through the dependencies in complex systems. And it means that, for example, in some cases, you don't get a simple distribution on the outside, but because there is interference between multiple elements of the system, you get interference patterns on the outside distributions. And so it looks like a black box, but people can understand the rules. They can change the rules of the play. And then, for example, if a company finally understands how this environment works, and they like the numbers that come out in a slow way, because simulation still takes time. And then there is a way to optimize the computation, saying, okay, these are the numbers that we're getting out of the simulation, and let's swap to the differential programming directly with the probabilities to get the same numbers, but in a faster way. And it's just performance optimization. So that's how I would normally approach that.
What is very interesting is that during the last year or so, a new class of tools, those LLMs, have become available. And that's very interesting because that's literally an entire class of technologies that have been around for, I would say, half a decade or so, but they were very niche, and only, I would say, experts would really fathom their potential, because it was mostly about potential at the time. And so maybe how do you see, what changed by introducing this class of tools of LLMs? How do you compare that? We had those to do essentially machine learning for companies. We had various classes of tools, classification, regression, Monte Carlo simulations. They were class of tools that could be put together, and now we have like another class of completely different tools, those LLMs. Maybe for the audience who might not be familiar with LLMs besides, ChatGPT, how do you wrap your head around in a context of enterprise, enterprise software organization, enterprise workflows? What is your high-level vision on that?
I've been working with or in touch with language models since year 2018, before the ChatGPT came out and made it popular. And you're correct that they were really niche. They would be used in language translators, voice recognition, language models that fix spelling errors, or that help to find text in large corpus. And when they came out with the ChatGPT, their popularity surged. One reason for that is because they were trained to be helpful and obedient to people. And that's actually sometimes why they are so irritating, because when you want to get the results out of the model and it starts apologizing, like, I'm sorry, I'm sorry, I'm sorry. And in my mindset, I basically separate two models on a large scale between two categories. One category of models, they work mostly with numbers. So we're talking about the regressions, we're talking about Monte Carlo, we're talking about neural networks. And the other class of models, which are large language models, yes, they work with numbers, but like on the surface, they work with text. They work with large unstructured text. And that's where their core usability comes from, because these models allow machine or automation to be plugged directly into the human interactions. Whereas, for example, with the regressions, with the time series, you need to plug the model somewhere in the middle of business digital processes. Like there is a database on the left side, there is a model forecasting engine, and maybe there is a database or a CRM or ERP on the right side. In the nice case, you get a report, but it's still numbers. With LLMs, you plug directly into the middle of business process, in the middle of the human workflows. And this creates so many possibilities, especially since it doesn't take a lot of effort to implement something that was completely impossible or expensive a decade ago. And for example, personally, when I'm working with LLMs, I start feeling right now that I got my own private department of assistants, which are polyglot. They're full stack. They're maybe sometimes naive, but they're also intelligent. And they will never complain about me asking, for example, to move a button on this layout, or rewrite this letter to the magistrate in Germany, or whatever. It's very helpful, very obedient, sometimes stupid, but they can do great things. And in enterprise, classes of the LLM adoption that I've seen, it's mostly in what they call business digitalization. So helping companies to automate the workflows revolving around finding text in a large corpus. Like, for example, a company has a lot of data. They have their knowledge bases, but these knowledge bases are essentially silos. It could be RFCs, it could be questionnaires, it could be Wikipedia that nobody really keeps up to date. And people need to do some activity. And activity sometimes requires finding information in obscure places. And this requires time, effort, and especially cognitive energy. And what LLMs can do is they can do some preparatory work. They can draft articles, they can do research on companies' private data, saying, okay, so you're, for example, compiling this answer to the enterprise. So based on your company workflows and the coded prompts, like, this is my draft. And for each item in this, for example, a response checklist, this is where I got the information. So the person no longer needs to do the routine work, maybe. Person can shift into the more highly intellectually demanding work of checking if the model got something right. And this allows to scale companies' efficiency massively. And while on the scaling part, people were, when ChatGPT came out, people were really afraid that LLMs and AI will take their jobs. But they do not. Trust me, I've been helping customers to make products that are powered by LLMs and ML for quite some time. And it takes a lot of effort to produce something that can replace a human. It's nearly impossible. But what LLMs can do is they can make existing employees more efficient, 10 times, sometimes even 100 times, but these are exceptional cases. They just make people more efficient, but they can never replace people. There has to be always people in the loop.
Well, actually, if I can follow up on that point, because again, the context of the discussion is generative AI, LLMs in the supply chain context. From what you just said, Rinat, it sounds as if your description makes it sound as if LLMs will be productivity boosters in general, but do you see there being any specific use cases within supply chain? Or is it just, as you said, I have a team of polyglots, I need to translate this RFP into 10 languages?
So here, in my experience, supply chains are a bit slow to adopt LLMs at the core of the process. LLMs rather start creeping from the outside. So a common case is the marketing departments are usually the first adopters. And I understand that is not the direct answer, but like these are the cases that I've observed. So when a company has, for example, when they're facing users, so this edge between the company and the users, the customers, it's where I have seen the biggest adoption. So for example, there are marketplaces that are selling products to their customers, and they want to make this interaction more pleasing and maybe reduce cost of having this interaction with the customers. And this means that, for example, ensuring that the product description and all the technical specifications are correct, because otherwise you'd have to return products, you'd have to pay for the shipping costs, or you have lower customer satisfaction. And it's already quite feasible to build systems that automatically crawl through the product catalogs one by one, restlessly, tirelessly, 24/7. And they see, okay, this is a product, but it was entered by the vendor of the supply chain incorrectly. Why? Because I crawled the internet, I found these product specifications, which are similar. I actually also found the PDF description from the producer of the product. And according to my belief, like half of the internet has this number right, and you have this number wrong. These are the references. Please make a decision if you need to automatically correct it. Oh, dear manager, I saw that you corrected this product description, this product property. Do you want me to regenerate the product description to have the updated number, like not just the number, but also the text? And while you edit, I created 3 product descriptions, so you can pick whichever makes sense. And I also created a CEO marketing text. I updated the keywords on your on your publishing engine. I also created a Twitter announcement and LinkedIn announcement. And that's one of the edges. Another edge between the customers and retailers that plug into the supply chain, it's the product listing on the marketplaces where people and companies do the product listings. So, for example, imagine you're a vendor that has to work with lots of marketplaces, and your catalog is 10,000 items and with small variations, like car parts, maybe airplane parts. There are lots of things. And you want to automate this process, especially if your own inventory changes quite fast. So it's quite possible, visible, and I've already seen this done. For example, you get a couple of images of the product, especially it's reused products, especially in fashion. It works really well. And for these images, you pass them through image recognition. It works best when it's trained on the fashion and styling. You get the tags, you get the descriptions. You pick the boxes bounding, you resize the images automatically. And out of that, you generate, first of all, description for the people. And then that's one of the nicest part comes. You create also LLM augmented hidden description that is used for the semantic search. What does it mean? So when a customer of a fashion platform tries to find a cloth, they would not always search for example, boho style shirt that has dragons on it, that is size M, and that is under 10 euros. They would search, hey, I'm going to a party tonight and my friends are boho. What can I wear that will complement my shorts? And if you have product descriptions and semantical explanations that were extracted by the LLMs from the product, and you search for them, but not for the full text, because who knows how people write Boho, but you use embedding-based search, so which is essentially a vector-based search, which is a search on meaning of the text, not of the exact wording, then you get results which on the outside look magical, because the model somehow starts suggesting you things that you meant it to ask it, not what you've said. I haven't seen a lot of use of LLMs directly inside the supply chain, aside from helping companies to do the workflow and usual business operations, but not the number crunching yet. But it starts to creep from the outside, from the interaction with humans.
Oh, thank you, Rinat. Joannes, your thoughts?
I mean, when I observe supply chains, I would say the white collar work spread pretty much, half-half. Half people are toying with spreadsheets, and the rest is mundane communications with partners, suppliers, clients, and whatnot. So the spreadsheets, it's really about automating the quantity decision. That's what Lokad has been doing now for a decade. The second part, it was mostly not automated because until the advent of LLMs, there was no real technology that was, I would say, a plausible answer to that. Meaning that the stuff that requires a communication, either it was a very, very tight workflow, and then it could be automated, and it was automated through, let's say, EDI. Pass an order, okay, we are going to have a bridge that pass the order, and then we have a non-textual problem. But that's not exactly what people, when I say people spend half of the time on spreadsheets, half of the time, managing partners, clients, transporters, suppliers. It's more like, could you expedite this order? If yes, at which price point? It's more fuzzy and open-ended. And so someone has to take this edge case and write an email on the case, kind of clarifying what is the intent, what is at stake, and whatnot. And that takes half an hour. And then you repeat with a different situation, a different problem. And you produce another email. And you end up with purchasing department where everybody, 8 hours of work during the day, they spend 4 hours on their spreadsheet and 4 hours writing 20 emails to 20 partners. And here I see a huge potential to improve. Lokad is literally automating the first part already, but with LLM, there is a huge potential to largely, but not completely, automate the second part. Essentially, letting people, I would say, providing support to compose communications that will be received by your partners, and where the LLM has been used to provide, again, free format, a reasonably contextualized version of the problem statement, and what do we expect from the partner. And that's, and again, the problem is that, I would say, if it was super simple, like passing an order, it has already been automated in many companies. So if the problem statement has well-defined boundaries and etc., then you have EDI. It just becomes something that is literally part of your fully mechanized workflow. Mm-hmm. But I'm talking about the rest, the things that are not quite aligned, such as you ordered 1,000 units, they delivered 1,050. You're not going to reject the order because they delivered 50 units. You like this supplier, so you will accept and validate the order. You will receive it, and you will pay for 1,050 units instead of 1,000 units. But you want to communicate in a polite way to your supplier that you would prefer if they stick to the original agreement, which was to ship 1,000 units and not 1,050. So you see, there is a little bit of nuance here where you don't want to disrupt the workflow. It's quasi-correct, but you still want to communicate that it's not OK to always push 5% more so that the supplier can charge you a little more for stuff. And this is the sort of things where LLMs really excel. This sort of soft communication where it's you need to convey a message. It would take time. you would like to balance the phrasing so that it's not too aggressive, but the partners still understand that you have a strong preference for them to have like strict adherence to the initial quantity that was agreed on. It's the sort of things where someone can, agonize over the email for an hour to write this half. And this is the sort of things where with modern LLMs, that's exactly the sort of things that is not like super intelligent. And the interesting thing is that the sort of intelligence that you have in those LLMs is linguistic. And if you want to set the tone right, they have almost superhuman capabilities. They are not necessarily super intelligent in the sense of getting the big picture right, getting the direction right. But if you want to have just the same text with a shade darker, like I want the same text but slightly more aggressive, or slightly softer, or slightly more supportive, they are super good. If you just say, just rewrite the same text but just slightly more supportive, it would take you, maybe for half a page, 20 minutes to do it, and an LLM can just do that literally in seconds. And that's exactly the sort of things where you can have like massive productivity boost for those soft touches where people literally spend hours and hours. And again, if I were to describe, core supply chain functions, half of the time on the spreadsheets, half of the times writing emails to partners.
And if we actually take this a bit higher, so imagine the company that has thousands of communications like that about the edge cases throughout the day. And that's a new capability that LLMs bring, is that normally for the business owners, for the stakeholders, to get the big picture, it takes effort. But now you have LLMs, which are very good at scanning massive amounts of texts and which are unstructured, and finding patterns at that. So imagine that LLM can actually read through all 100 of reports or emails or back and forth communications about, hey, stop sending us extra 5%. And at the end of the day, provide a very succinct summary to the exec saying, hey, we seem to have a repeating pattern here that more and more suppliers in the last week are trying to send us more stock. And this is not something that people would, managers would say. They would probably not complain, and the complaint would get stuck. But if there is a number that is too high, then LLMs that is running in the middle that can detect that. And also you mentioned spreadsheets, which is a normal thing, which is used still, and it's a very powerful tool for managing parts of the business. And that's also a very good place for LLMs to use. So as you have known, ChatGPT has an amazing capability called advanced data analytics. And this is literally feels like you have a department of data analysts under your control. They're not supply chain experts, so you'll need still a Lokad for that. But what you can do, you can ask them stupid questions like, hey, here's my database file, here's my Excel file. Run an analysis for me and spot the trends. And that's the amazing part, which is possible mostly only online. You cannot run it locally, or you cannot run it in the API. But the ChatGPT will come up with theories. It will then write a code, switching to a different modality. It will then execute a code. Then it will maybe hit errors. It will switch back to fixing mode. Then it will print out the results for itself. It will say, okay, the number looks like that. So then I'm going to write this chart for you. And then it will print a chart. And the entire flow from the moment when you send it an Excel spreadsheet and a question to the nice chart, it's fully automated. It's self-correcting, self-fixing, and you get nice results. So basically giving business decision makers maybe the ability to analyze data on their own, even if the data is stored in complex systems, to visualize it on their own, and without needing to know Python or JavaScript or C# or SQL, I think it's really empowering. And this kind of new solutions, new applications that help people that were not able to do something before, and now they can do that. This is, I think, opens new business opportunities and creates new business value.
This is very interesting because, now thank you, Rinat. About, I think it was 6 months ago, we did an actual discussion, just the two of us, on generative AI and its role in supply chain. And we were overall somewhat skeptical. When you listen to Rinat describe the advancements in just the last 6 months, do you still have the same perspective, or have you softened a little bit, Joannes?
No, you see, my position, and I remain deeply skeptical, is that on certain aspect, is that, my skepticism was essentially a reaction to most of the competitors of Lokad, who says, essentially they say, oh, we are just going to apply ChatGPT directly to terabytes of transactional data, and it would work.
And your demand forecasts.
And my take is, no, I don't think so. I don't think so. And I'm still very skeptical, and because it's literally that. Now, if you say something, but that's a completely different proposition. If you say that what you can do is list a couple of tables with schemas, or have the tool just auto-probe the schema of the database to say, please compute me, do me a disposable analysis, such as give me the average basket size, or something simplistic, something not simplistic, something simple, but that in the past would have to be run through the business intelligence team. And I'm talking of basic things like what is the average basket size, how long on average do we retain customers over the last 2 years, how much units have we sold in Germany? Very basic question, but I observe that in large companies, usually you have literally dozens and dozens of people in BI divisions that all day long produced, I would say, disposable reports, so reports that are going to be used only once, to answer like a disposable question, like how many clients over 1 million euro have we lost in Belgium in the year 2017? That's literally the question. And for these sort of things, I believe that LLMs can really help. But that's absolutely not what our competitors are proposing. Our competitors say, you know what? We have those models. You give them your terabyte database. You give them access to Twitter and Instagram. Done. You have your planning, you have the decision, everything, and it's entirely automated. And I say, no, not even close. We are not. We are in the fantasy world. And the interesting thing is that the sort of communications from those large companies, either by their competitors, but they don't seem to realize that in their communication, this difference that they mentioned at the very beginning, which was, do you have a class of tool that actually process quantitative inputs or textual inputs? And they seem to completely, mix the two together. And so my take is that LLMs are very good, as Rinat mentioned, to process large quantities of text. But when we say large quantity of text, we are not exactly speaking of the same orders of magnitude. A large quantity of text is 1 megabyte. For text, 1 megabyte is a lot. But when we deal with transactional data, Lokad very routinely process terabytes of data. I mean, Lokad in aggregate, we are now processing more than a petabyte of transactional data. So we are not even on the same scale. And yes, LLMs, because just to give you an idea, again, just so that the audience can have an idea of the scale, if I give you 1 kilobyte of textual data, it will take you 20 minutes to read it and make sense of it. So that's what we're talking about. 1 kilobyte of textual data is like super dense, super rich. So if I give you 1 megabyte of textual data, we are already talking of something that is probably several PhD manuscripts long. So that's already, that's not something. So it's a large company. Typically, if we were to take text format, nicely compressed and whatnot, a big division, let's say 200 people, and we take all the text materials that they have, all their, but not the mundane stuff, the high quality stuff, the training manuals and whatnot. If they have 10 megabytes of high quality textual data, that's already what they have. So bottom line, we are not even talking of the same sort of things. There are orders of magnitude of difference. And where I remain very skeptical is that to have these terabytes of data channel through LLMs. But channeling the textual data, no, absolutely not. And the sort of use cases also, we are not even talking of the same thing. Are we talking about automating the stuff that are already, fully quantitative, like EDI? I would say it's probably not a good fit. If you already have a workflow where the whole problem is entirely quantitative end-to-end, you probably don't need LLMs for that. But the problem is the other half of the problems where you have so many edge cases that are fuzzy. And that's literally, I think, where LLMs can shine, but that's absolutely not what most of our peers are actually pushing.
Rinat, your response to that challenge?
Oh, yes. So I have two thoughts to share. So first of all, about using LLMs to process large quantities of data. So I've been working with various LLMs for quite some time, because one of the first questions that customers usually ask, can I run this ChatGPT locally on the premises? And working with that, being able to answer that question requires benchmarking them in different configuration and trying to figure out the cost. And LLMs are quite expensive.
Yes.
So in order to run 1 megabyte of text through the LLMs, for example, for the prediction, it's going to cost you a couple of euros, depending on LLM. If you want to run it, for example, locally on the best available models, it will cost you 10 euros or maybe 20 euros. And that's what ChatGPT is actually doing with 3.5 model. It's very cheap. But the point being is you're not even capable, it is not possible to run terabytes or petabytes of numbers through the LLMs. And second, LLMs are horrible with numbers. And that's not the point. So if somebody is asking to LLM to do mathematical computations or calculate the prime numbers, or just list the prime numbers, this is wrong use. LLMs are linguistic models. They have a large mindset. They have very intelligent. They know a lot, although they still don't know very good. And you don't ask LLM a mathematical problem. Instead, you maybe ask LLM to phrase the problem, and then the computation will be passed to a specialized Python kernel or specialized something that will do much, much better than wasting this operation on LLM. And that's where interesting things happen. So there is basically the most interesting things happen when you have a touch point between different realms. And if we have, for example, numbers, like the vast numerical domain on one side, we have text or soft and fuzzy edge cases on the second part. And also the third part, it's code. So code is not numbers, it's not text, it's structured, yet it's verifiable. And LLMs but it's still text enough that LLMs are exceptionally good at that. And this creates new cases which might be applicable for the supply chain, which push their applicability of solutions like Lokad even further. So for example, one case where I've been applying LLMs to parse large quantities of text outside of LLM capabilities is that you phrase the problem to LLM and saying, okay, I have this problem. Like, for example, find me the text in a couple of hundreds of gigabytes of annual reports around worldwide, or help me to solve a numerical problem. But I do not want you to do the actual computation. You just come up with a theory of how to approach me because you're intelligent, you know the backstory, and these are the controls I give you. So if we're talking about the search across a huge database, I ask LLM in a specific syntax, come up with the embedding searches that I'm going to work for you. Come up with a list of stop keywords, or with the whitelist keywords, or the keywords that boost. And then another system that is dedicated for that is very good at processing at a scale. It will take this request from the LLM, and it will be already well formed, good enough, and it will run it. And that's actually where the best part comes from, because LLMs are capable of refining search. So then you go back to the LLM and say, hey, LLM, that was my original problem. That's what you thought about that. That's what the query that you came up with, and that's the junk that it returned. Please adjust and adapt. And then because working with LLMs is pretty much free, you just iterate that 10 times. Maybe you do a chain of thought, maybe you do a tree of thought to backtrace good decisions, bad decisions, and then it gets better. And the same is applicable to the numerical domains. Maybe at the edge case, for example, supply managers, they want to come up with an idea how to better balance their stocks. And in theory, I haven't been working with that directly. They can say, okay, this is a tiny simulation of my environment, which is maybe good enough. And this is how you can tweak it. Now, please do fuzzy constraint solving and try come up with the ideas that might help me to balance my stocks better, my inventory better. And while you're at it, here are the latest news articles. Here are the fashion trends. Here are a few other soft bits of textual information to give you inspiration. This is the possibility, and it opens up when you start bridging the multiple domains, numerical, code, and text, and you use the best tools available for each domain together.
Well, thank you. Rinat, Joannes, your thoughts on that?
Yeah, it's just to clarify for maybe the audience is that the interesting thing is that when you want, for a lot of problems, the way you want to approach it with an LLM is to say, please compose a program that will solve the problem. You will not say, I want you to solve the problem. I want you to compose a program, and then I will run the program. And then there are a bit, I would say, some further tricks, such as I can please compose a program, and by the way, I give you something like a compiler that you can use to check if this program compiled. Or I give you a tool that lets you run a little bit this program to check that the output makes sense. So you see, it's very interesting, but you see, it's not about having the LLM, like our peers are saying, solve the problem directly. It's mediated. So it's the LLM produce a program. It then use something that will, again, it's still textual output, because if you use a compiler, the compiler will attempt to compile the program, and if it doesn't work, will provide an error message. Error messages are good. LLMs love to process error message and fix the problem associated to the error message. But we are very much into the realm of text. And so, but then okay, so now we see, and that's the thing that is very interesting for supply chain, is that, okay, most of the situations will be mediated. So you will not, the way we will approach those problems with LLM will be, we want you to compose a program that will solve what I'm trying to do. And that's the same thing, for example, with this initial problem where I was saying, how much was the turnover in Belgium for last year for clients that are above 1 million euro a year? The LLM will not take the data from the database to do it. It will compose a SQL query that will run, and then the SQL query will be run by your database itself. That's the way. So again, mediation. Now, what does that mean for enterprise software? Well, it means that do you have, as part of your enterprise, software environments, the sort of platforms that support your supply chain execution, at least the decision layer, do you have programmatic capability? Because you see, the question is that so as we have just said, the LLM will not take the raw transactional data to produce the output. It will take your problem statement, produce a program, and it's very versatile in what sort of program it can produce, but it will produce a program, and then something in your environment will execute the program. Now the question is, what sort of programming environment can you provide to the LLM? And most of the classical enterprise software, they provide no environment whatsoever. They would just have the SQL database that has the language that you can provide, but then the only way to interact, let's say I'm using a big ERP that is supposed to let me optimize my inventory. Well, the ERP would tell you, the only environment that the software provides is you manually setting the mean and the max stock level or the safety stock parameter product by product. So there, the LLM can tell you, here is the recipe that you need to apply, but if you want to apply it, you will have to go through the manual ERP settings. Maybe if the ERP provides an API, it will tell you, well, I can compose a program that will let you do that at scale through the API, but it's going to be it's still very clunky compared to be able to have like a native programmatic solution. It will still be mediated through the framework. So bottom line is, I think it requires some profound changes and introduce, I would say, the programmability of the solution as a first-class citizen, which, by the way, I would say, shameless plug, Lokad has a programmatic platform. We didn't do it for LLMs. It was pretty much a fluke, but we still did it 10 years ago to have this sort of programmatic mindset as the core of the platform and as a first-class citizen. But that was just chance. That was not, I would say, a visionary insight about what would happen a decade from now with LLMs.
Well, thank you, Joannes. I'm mindful of everyone's time, so as is customary, Rinat, I will pass back to you for a closing thought. Is there anything you want to tell everyone who's watching?
So I'd say that there were a couple of bubbles in the past history. There was maybe a bit of dot-com bubble. There was maybe a finance bubble. And LLMs and AI, they might also be the bubble or might not. I use the fact that even my mother, for example, she knows about the ChatGPT and she knows how to use it and she can use it. And this is interesting time, and I encourage literally everybody to just, first of all, not be afraid of our machine overlords, because the Skynet will not work that easily. Like, for example, we have been promised agents, we have been promised a lot of systems, and as somebody who is trying to stabilize the damn thing in production, it's a lot of effort and it does not work reliably easily. So first of all, don't be afraid of LLMs. And second, just embrace it. If you embrace it or try to apply it, then LLMs plus humans and businesses can create a lot more value, especially when complemented by specialized tools, like, for example, Lokad forecasting that plug really well into the environment.
Well, thank you. And I think on that, I'll wrap things up. Joannes, thank you very much for your time. Rinat, thank you very much for joining us again. And thank you all for watching. We'll see you next time.